Three, two, one, go.
Good morning and hello to everyone. This is the first lecture of the lecture series which are going to be presented for the topic data structure for the BCA first year students, BCA 203 is the subject code. Today we will start our class from where we left over in the last physical class where we were presenting the theory classroom itself, and from today onwards up to the next notification we will be adding the online classes. So the spillover topic of single linked list which we were discussing the last day will be discussed today, and accordingly in your assignment you need to submit the online program of it. So the things which were discussed about linked list were first of all, linked list is a data structure, linked list is a linear data structure, linked list is a dynamic data structure, dynamic in the sense that the memory elements, the unit is known as node, comprising of the data part and the next address part. All of these things have been already discussed in the class. They are allocated, the nodes are allocated as per the user needs, so dynamic in nature. So a linked list is actually a collection of nodes. As you can see in the virtual diagram, memory diagram, you have three nodes into it. Just continuing from the example where we left over the last day. This was a very example. Actually, you are looking for the list 10, 20, 30. So if you put it inside an array, which is a static data structure, it will look like something like this. But I'm trying to get the same list, but using a node kind of thing, which is a linked list. So now this list looks like this. This is the data parts of 10, this is the data part 20 and 30. And now we have the other part in the node. There is the address part, it's pointed to the next address of the node. So 500, 800, and then the last one node. It doesn't refer to anything, that's why it is null. And obviously another thing which is very important, a linked list is incomplete. That is the single pointer pointed to the structure first node, and it's a single pointer. It's a simple point in the sense that it's not a node. Mark the difference between the structure. All of these have two parts into it, they are bifurcated inside, but this is a single pointer. This is just a simple pointer which is capable of storing the address of the first node. That's why you can see just a single block. So what is the essence of it? The essence of the start pointer is to just point to the first node, so it gives the user an indication from where the list is actually starting. So now we have discussed so far the creation of a linked list, how to display a linked list, how to append nodes from the first, second, third onwards in this way. So the linked list which is looking like this, initially we had created three nodes into it. First node was created, then we appended two nodes, and this is the start pointer. So now we will start our third and fourth function. So we have done creation, append, and display. The fourth function is as you can see in the code, insert before. So what do I mean by this? By insert before, I actually mean I'm trying to insert a node. So what I'm saying actually, this thing is looking like this right now. And this is a start pointer, just a more simpler view of this one. But my objective when I'm saying insert before, I'm trying to insert a new node into the already existing linked list. What do I mean by this? If I say, so right now the linear list looks like this, and in an array, so suppose this is an array, some cells are already blank. So if I am saying that insert a value before 20, so let's say the value is 40. So now what I am looking for is to insert the value before or after, say this is before, so 20, before 20. So what does it make? Then the list will look like after insertion 10, 40, 20, 30. I'm talking about an array. There's the same operation I'm trying to do with the help of a linked list, which is dynamic in nature. So, what are the bottlenecks in array? As I have already discussed numerous times before. Look, the first thing, when you are trying to insert something into it, you must ensure that you have enough space, because array declaration is actually, static in nature. Suppose in a class, you have declared that yes, 20 benches or desks would be there. So at most 26 are allocated. That is static declaration. What is the benefit? What is the benefit of it? You don't need to declare, you don't need to bring in at the runtime. So what happens if you have, you have an accommodation capability of 20 students because you have placed 26. Now all of a sudden, someday 10 students turn up. So you are wasting upon 10 seats. That's the disadvantage of the static allocation, where you are declaring the thing at the very beginning. Another bigger disadvantage is that what happens if 21 or 25 students come up, or in other words, more than 20 students come up? Then what will happen? You are found wanting with the space. You do not have the enough space to accommodate extra students because you just have the capacity of 20. That's what is happening. You are trying to insert a new node, but if you do not have enough space into it, you will not be able to insert. Even though you want it, it is your necessity. So one thing you needed to keep in mind when you were using array, that you had allocated at the very beginning, initial declaration, enough space to accommodate more elements. So if we were not accommodating more elements, we were unnecessarily losing out on some valuable memory space. That is the main disadvantage. So what I'm saying, look, now suppose I think that yes, in my array, I have enough memory space. So what is happening now? To insert 40 just before 20, I have to make sure that from 20 to 30, from 30 to 20, first thing I need to do is to right shift all the elements by one single space. So when I'm right shifting, this 20 goes over here and this 30 goes over here. So it eats up valuable memory shifting time. The whole process becomes very tedious. You are not able to straight away insert the thing into the linked list or into the list. So first of all, you need to right shift all the elements up to the last element, starting from the very element before which you are trying to insert, and then you need to make this place vacant, and then only you can insert 40 before 20. So two immediate bottlenecks where you are trying to insert an element before an element. One, you must have, in array I am talking about, you must have enough memory space to insert the new element. And two, when you are trying to insert an element before a particular element, from that element till the last element, you need to right shift all the elements by one place to vacate the position where you are trying to insert the new element. So after insertion, the list in array, which is a static data structure, again I am telling you, will look like this. Now look, when I'm trying to, now in contrast, when I'm trying to say do the same thing using the help of a linked list, how would it look like? 10, 20, 30 now. So now to accommodate 40, first of all I need to allocate a memory space to accommodate 40. And then the three tasks that I am left with, because I am wanting it to be inserted before 20. So what will happen? 10 was now pointing to 20. But now revised picture will look like 10 will be now pointing to 40. That's it. And 40 will be now pointing to 20. That's it. Now look, just by changing two address spaces, I am serving my purpose. Imagine it's an array which is of size 100 or 1000, and you are trying to insert something before the second element. So if its size is 100, you need to make from 2 to 100 99 shifting operations before you actually insert the element into the space, provided you have enough memory space available. So mark the bottleneck. I am needing 99 right shifting operations, which is taking a lot of time for the simple insertion operation to be actually executed. But mark the difference. Whatever number of elements or nodes may be there present in the linked list, you just need to make two operations. One, you just need to change the address which was pointing to this one. 10 was pointing to 20. Now I am just pointing into 40, the newly allocated memory node which is containing the data 40. And 40 will be now containing the address of 20. That's it. That's I'm done with. Let's see how we actually make a progress of this very operation with the help of a code which you need to execute during the lab class, and also send me the online assignment tomorrow. Look, initially the node looks like this. Absolutely fine. The node is looking like this. I mean, not the node. The linked list is looking like this. Now what will happen? I am in this very line. Struct node, you know, this is self-referential structure. It has been discussed before. These things, actually the structure is of the type of structure itself, because it's known as self-referential structure, because the structure itself, the address part of it is holding the address of another structure. That's why struct node. These things have been elaborately discussed in the class, so I'm not going there. So I'm allocating two pointers of struct node type. One is temp and one is q. So if this very line is executed, the virtual memory representation, how does it change? Immediately a symbol pointer temp and a symbol pointer q is allocated and created at the memory space at some memory area, say 50, and this is at 70. I'm just writing this as random. So after the execution of this line, the memory which was looking like this, the memory image, has changed to this image. I hope you are understanding this. Then I'm taking a variable, integer variable n. You know that what n will do, it will just hold before which element I am trying to insert. I'm coming to that. Now this block of code, if start equals to null, it was discussed in the last three programs, and not programs, last three functions. This whole thing means if the list does not exist. Say at that time, you know that start equals to null means start is pointing to nothing. That means the whole list is absent. That's when you are not actually having the list, so you need to use the create function. That is fine. Now coming to this one, enter the element before which you want to insert. So I hope right now, so this thing is not executed if this is the picture, because start is no more null. The condition, initial if condition, start is holding the starting address of the first node. So this whole block will not be executed, will not get executed. So the control from this line, the control will jump to this line itself. So the whole block will not get executed. That means the list is already present, it is not empty. So coming to this, printf, enter the element before which you want to insert. So I am asking the user where you are trying to insert the element, before which. I have three elements, 10, 20, 30, before which you are trying to insert. So let's say, and then I'm asking scanf, so I'm asking the user before, get the value. Let's say I give the value 20 over here. I hope you are understanding. 10, 20, I'm not able to interact with you. This is not an online live mode, that's why I hope you are getting it. If you are not getting it, text me immediately. I will just make everything clear. So up to this, it's pretty simple enough if you have done the previous classes. So I'm asking from the user that before which element you are trying to insert the new node, and then I'm scanning from the system, and if it is 20, then actually the memory image will look like I'm trying to insert something before this. So you have 10, 20, 30. So I'm saying before 20 something should be inserted. Good. Next. Now you can see that there is this thing, if start data equals to null, n is the element before which. Now if you look at this picture very quickly, there's a big concept which is lying over here. I say that there are two categories before when you're trying to insert a node before a particular node. There are two categories of insertion. What do I mean by two categories? Be very attentive over here. First of all, let's say I am trying to insert something before the starting node itself. In this case, starting node is 10. So this is one class. So what is that class? When I am trying to insert a new node before the starting node. Why I am just separately categorizing it? The need is that when you have the starting node, at that very moment, just this memory address changing will not be enough. You need to change something else. Only for that very rare case only, which is the starting node insertion before the starting node. Say if I write before the element 10, 10 means 10 is the starting node. So what is that very thing which is extra than all other cases? That very thing is that if I want to insert say 40 before 10, the picture will look like 40, but in that case, so now 40 will, I'll come back, 40 will now point to the first node, but in that case only, the start node has to be now adjusted, start pointer. So what I'm trying to mean, 40 will have the address of 200, so now 40 is chainly pointing to 200, but this is not everything. I am needing to change start pointer, which was initially pointing to 10 as the starting node. Now it needs to be updated and it needs to point to 40. That is the extra task which is needed only when you are trying to insert a new node before the starting node itself. And as I said, there are two classes of insertion. One, a special case when I am trying to insert a node before the starting node, where I am needing to update the memory space address of start, and all other rest of the classes for the non-starting nodes. So from the second node to till the last node, if I am trying to insert before it, I do not need to change the start pointer, because start pointer will keep on pointing to the first node. So I am not tinkering or changing over the starting node. So I hope you have understood. So I need to take special care about the starting node, and this if block does exactly that. It takes care of the starting node. Now, how do I figure out? That? Let's say I'm just trying to insert a new node before the starting node. Right now the picture looks like this. How do I figure out before the starting node? Well, this is the way you do it. If start, I'm referring it, if start data equals to 10, n means I have given the value 10. So what does n mean? N means 10. So what is the data inside start? What is the data inside start? Just having a technical problem. Look, I'm saying start, I'm checking if it is n. If it is 20, what is the data inside start? Start is pointing to this, so the data part is 10, yes. When the data part inside start equals to n, in that case only you mean that you are trying to insert a node before the starting node. But if start dot data is not equals to null, let's say I have given the enter the element before which you want to insert is 20. So what will happen now? This n is different from the start data, so the whole if block is not covered as yet. The whole if block will not be executed, we will jump to the next condition. Let's say I am trying to insert something into the start data. So what will happen? So this. Now I am dynamically, you all know this, I am allocating a memory node dynamically with the malloc function, and it is the pointer casting, and I am saving it inside 10. So what is happening? One by one I am dynamically allocating one node with the malloc function, that is the size of struct node. How does the picture change now? a node. Mark the difference. It has two parts. They have only one part. They are simple pointers to the structure node, but this is a node, and I have allocated this memory space via this line with the help of this dynamic memory allocation function malloc and the size of struct node. And then because it returns the address, a void pointer, but I'm pointer casting it and storing it inside the temp. So now, if at random, say it has been created at memory space 900, it may be any value. So what will happen? Because the starting address of this newly created node is 900 and I'm storing that address, so in temp now 900 will be the content. And what will happen? Actually that means temp is now pointing to the newly allocated node. Is it understood? So first of all, we need to say in a class there are 5 students and we have placed 5 benches. All of a sudden a new student comes. So first thing, it is a dynamic, not static, where we have placed so many benches straight away. Now according to my need, I need another bench. First of all, I need to place that bench. So that bench is being placed. Now we need to allocate the students or make the students sit at that place. We will go through. So but the allocating of the seat is taking place at this very point where at some place in the classroom I am allocating memory space and temp is pointing to that. Now enter the element to be inserted. What is that? I have said that 40 needs to be inserted. 10, 20, 30 was the list. 40 needs to be inserted before 20. I have taken before 10 here. I am talking about starting. So the data which needs to be inserted, the data part before 10 is now 40. So that's why I am writing in this very line scanf percentage temp data. So temp is pointing to this and its data part. I am asking the user and you put in 40 over there. It is as per your wish. That's why it's been asked dynamically using the scan function. So right now up to this line, this very thing, the picture of the memory looks like this. And then temp next equals to null. So straight away I put null over here. Now the students, ask yourself, in the class I normally ask, if this is the picture and if I am trying to make a list like which was initially looking like 10, 20, 30, now it should be looking like 40, so 40 needs to be placed before the first element which was previously 10, now it will be 40. So what are the changes it should incorporate? C++ is that you know that C is the globally declared counter variable. Because I have inserted one more node, C++ will know that. Now, what should be done? I have written temp next equals to start. First of all, look, this thing, if I bring in 40 over here, so this will look like this. Actually, I am trying to do this. So what will happen? Temp next was initially null. So this part has been written as null, but this part should contain the address of the first node itself, which was initially 10 and the address was 200. So what I am doing in this line, I am writing temp next equals to start. I hope you understand it is very same like append. So what I am doing, start was initially holding 200. 200 means this address space of the previous first node. So now I am writing temp next equals to start. So start's address is now assigned to the newly allocated node's address. So now it becomes 4200. So what happens? Now the picture changes to, let's say this. Now the picture changes to temp is pointing to this 4210. So look, we have successfully brought in 40 and 40 is holding the address of the first node, previous first node. Now it is acting as the second node. We are done? No. We are still not done with. Why? That's why I mentioned this case as a special case. Starting case, one class, and non-starting nodes all belong to the different class. Why? Just the changing of this address links is not enough. I have to also change. Look, start is still very much pointing to the previous first node, which in turn is now the second node. So we need to change, and this 40 was created at memory space say 900. So what we need to change? We need to change the direction of start. Start now should point from here to here, as if to indicate, yes, now it is the starting node. So what will happen? Start should hold the address of temp. Temp is holding the address 900, and the minute I am writing start, assigning start equals to temp, the temp value is 900, and the picture now changes from start is no more pointing to this one. Now start is also pointing to this one. So look, the whole thing is now looking like start is holding 900, new node, then new node, then new node, then new node. This ends the first part of it.
Function F5. Function F5. Should I take a pause?
Now you can see that if block for the starting node, insertion before the starting node to be precise, has ended over here. And because return, that means if you were trying to insert something before the starting node, it will encounter this return statement, it will go to the main menu. It was a switch case program. So from this part to the next part, we will not be executed. But what if the picture looks like this, where you have a linked list, say 10, 20, 30, now start. Now I am trying to say that I will insert a node 40 say before 20 or before 30. So all of them belong to the second class itself, where you are not inserting the newly created node before the starting node. So what is the lesser task? You do not need to change the start pointer. So let's see how it will be progressed. So when I am coming here, it means definitely I have not encountered the first if statement. If the first if statement was not true, and first if statement implied that I am trying to insert the node before the starting node. So if you are here, you definitely know that you are not trying to insert a node before the starting node. If you were trying to insert it, that if statement would have been executed, and by no means you could have been here. So the minute you are here, that means the whole statement was skipped because the condition failed. So here you are trying to, the minute you are here, you know that you are trying to insert a node before the non-start nodes, from second to the last one. Let's see how it works. So you can remember there was a simple pointer to the structure node temp, and there was another thing q. I am saying, so starting is holding the address of this. So I am saying q equals to start. So now q will hold the address. So this is 200, this is 400, this is 500. So this will have 400 into it, this will have 500 into it. I hope this is clear to all of you. So now what will happen? Q 200. And what is the purpose of Q? All of you know that this Q is being always used. You did it for the display. It is used for the traversal. So you are always now saying Q equals to 200 means I am pointing to the start node itself. That means from start I will make a traversal. I will traverse or walk up to the node from which you are trying to operate upon, before which you are trying to insert. Let's see how it progresses. So while Q not equals to 9. So what is the value of Q right now? Q is holding 200. So Q is not equals to 9. So this while loop initial condition is satisfied, you enter into the loop. So what is now? It is saying that Q next data. It's a fantastic thing. Q next data. What does it mean? Q is currently 200. 200 means the starting point. This is the next part of it. You know that every node has two parts into it. This is the data part and this is the next or the address of the next node. So when I'm saying Q next, Q reference the operator next, that means 400 means this one, and I'm saying Q next data, that means Q is 200, Q next is 400, each data part is this, so 200. Look. So if Q next data is equals to n is what? Enter the element before which you want to insert. So if you had wished that initially this looks like 10, 20, 30, I will be trying to insert 40 over here, so I have given 20 as a variable. Before 20 I am trying to insert a new node. So in that case Q next data equals to n. Be very careful if you have any doubt, it's a very tricky one. If you have any doubt over here, you can ask me in WhatsApp or anything, or when the class resumes, that what is this? Now temp. So let's say this is satisfied. I have given at that line that I am trying to insert a new node before 20, and so this condition is satisfied. So what happens? Customary things that happens. So I have reached up to that point before which I am trying to insert a node. So what is the thing which we have already done? I need to. So I know the student, new student. The new student has come. So now what is my next task? My next task is to bring a new disk into the class. So I need to allocate a new node into it. So that's what I am doing with the malloc function. Looks like this. Let's draw this over here. It will be easier to explain in that way. So a new node has been created at, say, memory address 1000 with a magnitude. Fine. Enter the element to be inserted. So its data part 40 as I have already drawn. So you scan the value and temp data. So temp is now holding 1000. As always, temp points to the latest allocated memory node or newly allocated memory node. So temp and temp's data is given as 40 by the user himself, and temp next, it's a practice equals to none. So you tell yourself what are the tasks needs to be done. I need to have 10, then not 20, 40 into it. So 10, which is pointing to 20 and which is pointing to 30, if 40 arrives, what will happen? 10 should no longer point to 20, rather 10 should point to 40, and 40, this next part of 40 should be pointing to 20. These are that line start should be unaltered, should always point to the first one, that is the second class I am talking about. I am not inserting the node before the starting node. So I am trying to insert before the non-starting. So these are the two things which we need to do. Let's see what happens, whether we are doing it or not. C++ actually increases the number of nodes. No need to discuss it. It's been discussed in the theory class. So it counts the number of nodes, just increases it. Temp next. Now take a look at this line. Temp next equals to Q next. So what is that? You tell yourself before I explain. Those who are watching this video, just tell yourself. Temp next means what? Temp is pointing to the newly created node. Its next part is null. So I am actually referring to this position only. And according to the picture I had just drawn, this should be having the address of what? It says Q next. What is Q right now? Q is pointing to 400, which is the address of the earlier second node. So when I am trying to insert this over here, this part should be pointing to this part. I hope I am clear to you. So Q next, earlier, this part, Q next, Q was the starting node and Q next means 400 means this node. So now I am saying the Q next should be assigned into temp next. Temp next means temp next was null, so I am writing 400 over here. The minute I am writing 400 over here, what does it mean? It means 400 means the picture looks like this. I draw a vector picture of it. Initially it was 10, 20, 30, simple, very simple, 40. So I am saying Q is pointing to this and start is also pointing to this. Q next means this one, and this one should be the next part of this one. Now, so the minute this line is executed, temp next equals to Q next. This means this one is now pointing to this one. So now if it is 400, if it is 400 over here, this part will be 400. So one thing is done. So which thing is still left to be done? So I have made the connection that yes, this should be pointing to this. But still one thing is left to be done. What is that? This thing should not be pointing to this, rather this thing should now hold the address of, it is being created at memory space this. So look at the very next line. Q next means Q is pointing to this. So Q next was earlier 400, and I am saying that Q next equals to temp. Temp means temp is pointing to the new. Temp is a pointer, you know that. Temp is pointing to the next newly created node. So temp next means now this one should be having, temp means temp's value is, look at this picture, temp's value is 1000. So I am saying Q's value, which is this one, should be now temp, means this whole thing now, this change is here, and it should now contain the address where Q is pointing. So now the whole picture, it was looking like this: 10, 20, 30, 40. So we have made the progress till now, but the problem was that both this one was pointing to this and this one was also pointing to this. But actually we need to change this one from here to here with the help of this line. Q next equals to temp, because temp is holding the address of the newly created node. So temp is 1000 and Q next, it was earlier 400, now it's been changed to 1000. So the picture looks like this. So look, with the changing of only these two lines, I am able to insert a new node before it. And as you know, Q equals to Q next. If you want to insert before 20, before 30, you have this Q equals to Q next. So you made a traversal in the last node. It's absolutely the same as the display function. Hope you have understood this very insertion before function. Accordingly, you need to also write down the insertion after function of single linked list also, and I'll check. So thank you very much. If you have any doubt, you can ask me or text me in my WhatsApp number. Thank you very much.